All right. Hey, what's up, guys? Happy Tuesday. You got a little asynchronous problem set here today, pages 110 and 111. I think it's about 5 or 6 problems. We're just going to go through the first two together with you because this kind of has to do with the new stuff from last week. Remember, we started a new unit called polynomials. Polynomials. Ooh, that sounds scary, doesn't it? Poly. Well, the word poly means many in Latin, and the word nomials means terms in Latin. So that just means many terms, okay? X squared is a term. This here, another thing, x squared is another term. We can combine those like terms, right? We can add them together. X is a term, another x is a term. We can combine those, that's 2x, 3x, 4x, 5x, so you can count them up. Anyways, many terms. So polynomials, right, if we have many terms strung out together, oftentimes, well, not oftentimes, sometimes you can take your polynomials, and if you have algebra tiles kind of like this, you can create a rectangle, and that's pretty neat, right? Create a rectangle. I'll go ahead and outline the rectangle right here. So I'm going to do 349 first, then I'm going to do 348. So anyways, you can create a rectangle out of this particular polynomial. And when something neat happens, when we're able to take all of our terms, set it up as a rectangle, right, using our algebra tiles, we can actually describe what this polynomial is. We can write it as a sum, okay, or we can write it as a product, okay? Because remember, our polynomials, our specific terms, get named based on their area, right? Their area, the space inside here, okay? So if we can get it as a rectangle, we write it as a sum, write it as a product. And this polynomial will be something called factorable. We're going to get to that later, right? It's all going to connect. It's going to make our lives easier a little bit later in the semester if we understand how to do problems like these pretty quickly right now. So anyways, looking at this polynomial right here, we can write it as a sum, okay? Write the area of the rectangle out right as a product and as a sum. Well, I'm going to do the product first, okay? So product, what does product mean, right? Product means we're multiplying, okay? Sum means we're adding. Okay, adding here. All right, so what are we going to do to write this as a product? Well, how do we get area in terms of multiplying stuff here? Yeah, that's right. We got to do length times by width, right? Or base times by height. Or bottom times by, I don't know, length times by height, base times by width. About right here. Or length times width and base times height. Anyways, right, you know how to do area of a rectangle here. So check this one out here. This might be a little bit hard for you guys remembering this one here. We got this x squared piece right here. That's the inside. So the sum's actually the easier thing. It's funny they say product first. I'll do a product for you guys anyways there, though. So this is x squared here. What I'd recommend when you do problems like these is actually to label the outside so that we can figure out, right? Remember, width or length times by width is going to be our area as a product, okay? And so I would label the outside here. This is an x squared piece. Well, I know an x squared piece is just x times by x, right? X times x gives me x squared, right? 5 times 5 gives me 5 squared, which is 25, right? So x times x is x squared. Here, this is x times by x, right? And x times by x is x squared, okay? X times what gives me x? Well, x times 1, x times 1, x times 1, x times 1 gives me those 4 x's right there. So what I got kind of as my dimensions in the bottom, right, my length of this, is going to be 2x plus 4, okay? And I got a little messed up here. We can't really see what I wrote there, so I might kind of erase this here. Use my can and my build here, so you can hopefully see what I wrote here. So this is 2x plus 4 as our width, okay? So I'm going to write the area as a product. I know I'm going to multiply my length times by my width, or my base times by height, right? That's the formula for finding the area of a rectangle, base times by height. So I'm going to do 2x plus 4. Right? This is 2x in width, another, or length, I don't know, I'm just mixing my words here. 2x, and then here's a 1, 2, 3, 4, 2x plus 4. Okay, and that's going to be multiplied by the height of this, which is just going to be x. Well, I have an x down here, and then what brings me to x? Well, I multiply by 1, multiply by 1. So this height right here, from here to down here, this is going to be x plus 2. Right? That's x plus 2 in length right there, x plus 2. So here we go. We got our area as a product is just going to be x plus 2 times by 2x plus 4. We got our answer there. So it turns out that that's equivalent, okay, that's equivalent to writing it as a, you guessed it, a sum. And we're going to go between these two forms as the year goes along. It's a pretty important thing, right, to get into pre-calculus and whatnot here, to know how to do this, go between the two. So here, right, if this is a product, I could, we're going to learn how to multiply these things pretty quickly. Okay, because remember, when you see parentheses in math, that means multiply, okay? So I could just multiply this, figure out what it is as a sum, but hey, check it out here. What can I also do? Oh, I can count up. I can add up all the pieces I have here, okay? So as a sum, right, we see here, I have 2x squareds here, right? I got an x squared. I can add that together. Well, that's going to give me 2x squared, okay? So you should combine your like terms that you have here. If I have an x squared here and an x squared here, that gives me 2x squared pieces. Okay, I have another x. I have 1, 2, 3, 4, 5, 6, 7, 8. Anyways, hopefully do this fast for me. So there's 4 up here and there's 4 down here. So I have 8x. Okay, so I have 8 x's. Count them up. We got here 8 x's. And then finally, I have 1, 2, 3, 4, 5, 6, 7, 8. 8 ones. Okay, 8 ones down here. And there we go. We have our area as a sum, and here's our area as a product, and those two things are actually equivalent to one another. Okay, so later on in the year, we're going to figure out how I could change this, right? If you're just given this as a polynomial here, we got 2x squareds and 8 x's and then 8 ones. How can I change it to a product? We can do that too. And that'll be important, right, to actually analyzing some of the things we want to analyze this year about parabolas, specifically parabolas. So we'll look forward to that later this year. Okay, and then vice versa, right? If I have the product, how do I get the sum? Well, this is actually just multiplying here. Check this out. 2x times by x would be 2x squared. X times by 4 would be 4x's. Here's 2 times by 2x. That'd be another 4x's. There's 8x. 4x plus 4x is 8x. 2 times by 4 is 8. Oh, you see how it kind of connects? Anyways, we'll get practice about doing those quickly later. We'll do something called a foiling method, perhaps, or a generic rectangle method. So check this one out here. Let's do 348 real quick here. This is just to remind you, this is just prove to you that, hey, if this is 2x plus 4 and then x plus 2 here, those multiplied together would equal this whole sum here, or equal this whole sum here. So they wanted you to kind of do this one here, 348, first, to just remind you of that an area of a rectangle kind of like this here is that we can take this height times by this base, or this width here, width times height, or whatever you have here, so length times width. I could find the area of the rectangle, right? Find the area of each part and then find the whole area. There are 2 ways I can find the whole area, actually. I can find the area of the inside here, right? If I find the area of this part right here, 11 times 7, that's 77. 8 times 7, that's what, 56? Okay, get your calculator going if you're not totally brushed up on your multiplication tables, but you gotta be good at your multiplication tables. That is a requirement in high school math, right? If you don't know how to multiply really quickly like that, that's a problem, right? So study those multiplication tables for sure, because that's the biggest thing I see between people in terms of the speed and the ability to finish work. Multiplication tables, that's what it's all about. 11 times by 3, that's 33. Okay, 8 times by 3, that's 24. Okay, so check this out here. Find the area of each part. Well, each part is 33, 24, 77, and 56. Okay, 56 here. What does that equal? Okay, what does that equal? If we want to find the area of the whole, there are 2 ways we can actually do it. We can take all these parts and add them together. I just want to show you that area can be found 2 different ways. One is a sum, which I'll do right now, and then we can also find it as a product, which we'll do in a second. Okay, so we got here 33 plus 24 plus 77 plus 56, and that equals 190. Okay, there's the, right? So the sum of all parts, okay, these are sum of each part, okay, area of each part. And this here, right, if you're going to label your answers, I'd label them up like this. We got to get the area of the whole. This is the area of the whole, right? The area of the whole is equal to the sum of the areas of each part that comprises the whole, okay? This is actually something for you geometry folks that is an assumption, and it's a very obvious assumption here. If that's that area, that's that area, that's that area, that's that area, just add them all up, you can see the whole area. That's an assumption called the area addition postulate, which you'll get to later in geometry, if you're in geometry this year here, okay? But I just wanted to show you this because we could have gotten area another way, okay? Check it out. This is 190. What's another way we could have gotten area of this whole rectangle here? Well, we could add up each part, or we can multiply here. Look, this is 3 plus 7, so that's 10, okay? This is 11 plus 8, okay? So that is 19. And check it out here, right? Our area equals the sum of all parts, but it also equals base 10 times by height 19, right? Or vice versa, right? Base 19 times by height 10. 19 times by 10 is 190, and we're good to go, okay? Area as a sum does equal area as a product. Okay, and we'll work with that more in terms of polynomials as the semester goes along. Thanks for watching. Best of luck on the rest of your problems. Email me if you have any questions. I don't think it should be too hard today. We'll ease back into it, and more of this stuff coming at you tomorrow during synchronous class. Bye.